Hello, I'm Steve-O and welcome to the Outback Shed. My milling machine has a machine light fitted as standard. It's an 11 watt LED and it works very well. I supplemented this with a second light on the other side of the column, and it's also useful as a magnifier for fine work. However, they both create a problem with shadows and flares which restrict the camera placement and angles, so I decided to make an additional light that overcomes these problems. I'll make a ring light that will be mounted around the quill and provide light vertically around the cutter. I have several requirements for this build. It must not be physically attached to the mill. I don't want to use nuts and bolts to attach it. It must be independent of the mill electrical system. It will be 12 volts, so it won't work with the mill systems anyway. It must be easily removed and replaced for cleaning, or if I don't want to have it fitted for a particular machining setup. It must not be affected by oil or coolant. It needs to look like it belongs and is part of the machine and not just an add-on. I don't want it to shine light on my eyes during use, so the light must reflect downwards and not sideways. And it must be effective and just work. As a starting point, I had a look on YouTube to see what others have created. While there are some interesting builds, I didn't find any designs I really wanted to use, so I'll make my own. The ring will be 3D printed and I'll use PETG Pro filament. The parts I will need for this build are an LED light strip in cool white, which will be about 6000K in colour, an inline switch to turn it on and off, a 12 volt power supply of around 2.5 or 3 amps, a power board, some 8mm magnets, and of course some resin. I made a prototype to see how the components would fit together, but more to see how the resin would work with the LED strip. I made 2 wraps of strip and that came together alright, but the degree of brightness was not what I was hoping for. However, it does a good job of illuminating itself. It needs to have angled surfaces to reflect the light downwards to the workpiece. A quick sketch and I have an idea to have 2 rows of strip mounted vertically, with each shining against an angled surface to provide downwards illumination. As the LED strip is 10mm wide, if I made the mounting surface 25mm, I could accommodate 2 wraps of strip in each row. I'll design the housing using FreeCAD, then I'll 3D print it. As my quill is 105mm in diameter, I'll make the inside dimension 107 to provide some clearance around the quill. The outer diameter will be 180mm and I'll make it 30mm thick, as that works well with the diameter of the head casting and the location of the bottom of the spindle. It will also provide enough space to locate the magnets. I want 2 rows of strips, so I'll make 2 grooves 25mm deep and 5mm wide, one for the inside ramps and the other for the outside ones. Next, I want to drop the height of the metal section by a couple of millimeters so that it will sit underneath the surface of the resin. Creating the angled reflection surface is simply a matter of putting an unequal chamfer on the corner. I'll do this by eye and just take the chamfer to the bottom level of the groove. The angles are not 45 degrees, but I don't think that'll matter too much. Well, we'll see how the finished light performs. I'll put a 2mm round on the inside edge and a 1.5mm round on the outside edge. Turning the ring over, I'll make a pocket for a magnet. The ones I have are 8mm by 3.2, so I'll make the pockets 8.1 in diameter by 3.1 deep. This will allow for a tight fit and for the magnet to sit slightly proud of the ring, which will make it better for seating on the mill head. It's a simple matter of then creating an array around the ring. I settled on 16 pockets to give me multiple options of the number of magnets I might want to use. A 2mm round on the inside of the top face and a larger round on the outside for aesthetic purposes. I didn't have a number in mind, I just made what I thought looked right. I settled on 14mm. I'll need to cut a channel for the electrical input. I'll drop a 4mm wide groove in the outside of the ring using the pocket tool. Finally, I need to create a gate for the LED strips to cross over from the inside groove to the outside groove. Again, I don't have a specific size in mind, I'll just make it a size that looks right, and I'll pad this to the bottom of the groove. The outside corners will need to be rounded off to allow for a smoother transition of the strip between the grooves. That's the design now complete, and I'll save the drawing and export it as both STL and step files for printing. I can now drag the STL file into the build plate in the Slicer software. I'm using PETG filament and I'll left the settings on default. This print should take around 4.5 hours. I made 2 rings, one blue and the other grey. I'm using white epoxy enamel paint to create reflective surfaces. I applied several light coats to obtain an even finish. However, I'll try keeping the paint off the adhesive surfaces for the LED strips. The LED strip is metal backed and it doesn't bend or flex easily. It bends around the ring okay, but the transitions from the bottom to the top wraps proved difficult and resulted in parts of the strip having some deformation with a less than perfect adhesion to the ring. The 4 wraps of strip used around 1.7 meters of LED strip, so it should be bright. I'll plug it in to make sure it works before I mix up the resin. It looks very bright. The channel for the wiring needs to be sealed before the resin pour. I'll use a hot glue for this. The resin is a 2-to-1 mix, and for each ring I'll use 200 grams of resin and 100 grams of hardener. I'll make a separate pour for each ring. This is a relatively small pour, and the best way I've found to mix it is to use a popsicle stick mounted in the battery drill. I'll need to transfer the resin back and forth between containers to ensure that there are not any dead patches. I could have put the final mix into the vacuum tank to pull out any air, but for a small pour and where the resin is not visible during use, I didn't think that was necessary. I'll pour the resin in slowly and let it self-level. Then I'll use a small flame to remove any bubbles that come to the surface. I left the rings for a couple of days to cure before installing the magnets. A small drop of super glue in each pocket will ensure that the magnets will be there to stay. But as I found out, putting too much glue in the pocket made the seating of the magnet difficult due to the excess glue tending to hydraulic. I reckon 8 magnets will be enough, but I can always add more if needed. A paint tin opener is the perfect tool for installing the magnets. The final part is to apply clear coat to seal the ring and prevent any oil or coolant ingress. For the blue ring I'll use a semi-gloss, as this will provide a degree of diffusion to the light. The grey ring will be full gloss, and it should be the brightest possible for the number of LEDs used. I did consider using an orbital sander with a 320 grit to roughen the surface and provide a high amount of diffusion, but that may be too aggressive and I wouldn't be able to go back from that. But I could always do that in the future if the semi-gloss finish doesn't soften the light enough. I'll apply a couple of coats to each one and let them dry for a couple of hours. A comparison of the two shows the difference in clarity. Installation is easy. The ring is held to the bottom of the head by the magnets and sits around the quill. The 12-volt electrical connection is just plug and play. I mounted the power board on the cable management track and ran the wire through a piece of loom tube to keep it neat and tidy. The on-off switch is held in place by a piece of sticky back Velcro. Changing the rings is easy. Just unplug, remove, refit and plug it in. I lowered the table to provide an opportunity to compare the output of each of the lights. The ambient light around the mill is 200 lux. Switching on the machine light, the lux meter jumps to 480. The secondary machine light provides up to 900 lux, and it's a softer light as it's fitted with a diffuser. The grey non-diffused light produces nearly 1800 lux. Wow, that's bright. That's a lot more than I expected. The blue diffused light provides more than a 1300 lux, which is about what I was hoping for from the non-diffused light. I set up a piece of scrap aluminium and I'll drill 3 holes. The first one will be drilled with only the machine light. This shows a large shadow. I drilled a second hole with the machine light and the addition of the secondary light, but the shadow is still present. The third hole will be lit only by the ring light. It's much brighter and there are not any shadows. That's just great. If I make another ring light, I would possibly use a light strip that is dimmable. That might give more control of the light intensity and allow for some fine tuning during filming. Well, this has been a very successful project that didn't cost a lot. I'm very pleased with the performance of both of the rings. I'll be setting these lights up on both mills and I'll also design one for the drill press. If you have a mill of your own, this is a must-have addition and it's well worth the time and effort. Well, thanks for watching. I hope you liked the video, and if you did, please like the video. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.